We are entering a new era in computing, and it's not what we have seen for the past couple of years. It's not the generative AI era. It's really the agentic system era that perceives, plan, and also acts. And when you think about it, this is really how the human brain functions. The human brain is not about generating or even just talking. It's a combination of agents that we have in our frontal lobe, the back, the side of the brain. And those are agents that can reason in the frontal cortex, that can perceive close to the ears, the eyes, the touch, the smell, and so on, and that can direct our limbs to act. And that's really what agentic AI is all about. It really mimics more of a human brain than just generative AI. And of course, there is a feedback loop to learn from what your interaction in nature are. But in the case of agentic AI, it could be multiple objects at the edge, could be drones, could be cars, could be robots, that basically communicate, discover each other, communicate with each other. They have small brains that can take decision, talk to tools, and also can talk to the cloud when they need the big brains. And there is a learning step, but really the main workload is inference. It's inference and also using the tools. So inference at scale is really what is needed in terms of infrastructure for agentic AI and also the toolings that actually run on CPUs. So we're seeing huge adoption, not just at the edge and the endpoint, but also on the CPU side, the adoption is picking back up because we have millions and soon billions of agents basically calling those tools. So those are databases, calculators, and tools like that are being used by those millions and billions of agents. And of course, context memory is going to be much, much bigger in the agentic era than it's been in the generative era. And that's why we're building the full spectrum of hardware to support this agentic AI. So for the cloud, it's clear. It's the big brain. So we have GPUs that are basically inferring GPT-4o, XAI, and other big LLMs, frontier LLMs. On the endpoint, we have, for example, laptops that have inference processing units that are powering Copilot+. So if you have an NPU in your laptop, you can do things like live transcription and translation, which is something that won't happen if you don't have an NPU. So there is a Microsoft Windows tool for that. It's, I think, live transcription is the name where if someone talks or you're playing a YouTube video, it can translate and transcribe live using the NPU. At the edge, we actually have some really, really, really interesting use cases with AI at the edge. Obviously, autonomous cars, like for example, Subaru has a little AMD Xilinx SoC for the past actually 3 generations. Eyesight is powered by an SoC, which is not an ASIC, it's just an off-the-shelf SoC running computer vision first and now AI. And we have medical devices that use little SoCs that accelerate AI. The one that I like the most is Illumina, that's running genome analytics to quickly determine what's the root cause of a newborn baby that's born sick and only has a few hours to live unless you can root cause the problem and treat it. And literally, we're accelerating that genome analytics from days to minutes and literally saving babies' lives in the hospital because of that. And among my favorite one also at the edge are the CERN, the Large Hadron Collider, also uses a little SoC to gather the massive data coming from high-speed proton collision to discover new particles. So the Higgs boson, for example, was discovered with a little AMD SoC several years ago, actually doing AI. The CERN has programmed those devices to do AI. And finally, the fun fact is we have one of those AI chips also on Mars right now running around in the rover, which is also a self-driving car. So it's not just the big brain in the data center. The edge use cases are exploding. And on the endpoint with the Copilot plus pieces and things like that as well. And Agentic AI will use all of that together. So the communication is happening between those devices. And it's just a matter of enabling the software. So you have little container agents in the devices at the edge, in the endpoint, in the cloud, all discovering each other and communicating with each other. So software enablement is really important. And we believe that the AI era really should be open and collaborative. So our entire software stack is completely based on open source. So we're working with these partners and a lot more that I cannot fit in this slide. And basically from the very bottom kernel development to the very top pipeline building, it's all open source based. Kernel development is OpenAI Triton, which is an open source software that's completely GPU agnostic. You can write your kernel there and the compiler optimizes it, and you can go all the way up the stack. And that's how we're reshaping the compute era, basically by building the full spectrum of compute hardware and enabling it with open source. Thank you.